In this video, I'm going to be going through distance time graphs. So if you have a look at the graph here in front of us, we have a journey starting here and then going along and then ending up here at the end of D. So various things happen during this journey. So you can see for A, our object is moving at a constant speed. Then for B, when we just have a straight line, that tells us that the object is not moving. Then the object takes off again, but it's not that steep compared to A, so that tells us it's going at a slower speed. Then the slope gets a lot steeper, and that tells us the object is now moving at a fast speed. So it's the slope of the line, that's what tells us how fast the object is going. If you wanted to compare exactly what the speeds were, we would have a look at how to find the slope. And if you see here in yellow, to find your slope is the rise over the run. So what that means is, let's have a look at A. I'd draw a triangle, so that's going across 3 boxes, up 3 boxes. The rise is 3, because 3 boxes. The run then, that goes across, that is 3 boxes. So the slope for this, rise over run, will be 3 over 3, and that will be a slope of 1. For C then, let's join the dots. So we go across 2 boxes, up 1 box. So 1 and 2. So rise over run. So rise is going up, run is across. So that has a slope of 1 over 2. Finally then, for D, we go across 1, up 3. So rise over our run, that would be 3 over 1, which is 3. So we can see there that our 3 slopes, we have 3, a half, and 1. So you can see that D there, that's the fastest speed because that slope is clearly the biggest. You'll be looking at rise over run a lot more when you do the coordinate geometry chapter. Okay, let's have a look at this question here. So we want to find the slopes of A and C, and we want to see which is the faster speed. Okay, so let's get our slope first of A. I'm going to draw a triangle from the start point to the end point. So we can see we go across 4 boxes, that's our run, up 2 then, so that's our rise. So rise over run will be 2 over 4. That will simplify to a half. Now let's look at C. So let's draw a triangle from the start to the end point. So I'm going across 1, 2, 3, 4 boxes. And now I'm going up 1, 2, 3, 4, 5. So my rise over my run, that will be 5 over 4. And that's my slope. So we're then asked which is the faster speed. So if you're unsure of fractions, we can maybe change these into decimals. So 5 over 4, that would be 1.25 of a slope. And a half, that's 0.5. So we can clearly see that 1.25 is greater than 0.5. So C has faster speed. Okay, so using our rise over run, we're going to use that now to work out speed from distance time graphs. So remember your distance speed time triangle. And if we want to find out what the speed is, we cover speed, so then it's distance over time. That's exactly what we're going to be doing here. Because if we want to find the speed of this object, let's draw a triangle from the start to the end point. And we're going to read off the values here. So we can see the time there is 2 hours. And then the distance, it goes up to 60. So then we'd have 60 over 2, because distance divided by time. And that will be 30. And it's kilometers and hours, so it's kilometers per hour. Let's do another one. So here, again, we need to find our speed. So we can see our endpoint here. Our distance is going to be 120. Our time then, so if you want to draw down, is 5. So our rise over our run, our distance divided by time, we have 120 divided by 5. And that is 24 kilometers per hour. Okay, here again, so we have our distance, which is 80. But notice now our time is in minutes. So be careful with this. So one way we can do this is, let's just do the regular way. So we're going to have 80 divided by 40. So that would be 2. But be careful, this is now kilometers per minute. So we want it in kilometers per hour. So what we could do, so seeing as this kilometers per minute, I can multiply by 60, and that now changes it to kilometers per hour. So that would be 120 kilometers per hour. The other way I could have done it, the 40 minutes, that's 40 over 60, which simplifies to 2/3. And then I could have done 80 divided by 2/3, which would have also given me 120 kilometers per hour. Okay, I'll do this one quickly. So we have again 130. So 30 minutes, so that's 30 over 60, which would be 0.5. So then we're going to have a distance, which is 100 divided by 0.5. That'll be 200 kilometers per hour. Here we have distance in meters, time in seconds. So our distance is 20. Our time then is 4. So we'll have 20 over 4. That is 5. And our distance is in meters, so it'll be meters per second. So 5 meters per second is the speed of this object. Okay, so we'll finish with this one. Barry leaves his house at 4 o'clock to go shopping. The graph displays the distance from his home to the supermarket and how long his journey took. So the first question there, how far away is the supermarket from Barry's house? So that's an easy enough one. So reading from the graph, so I'll just go to a separate page for this. We can see that that is 30 kilometers. The next one then, so how long did Barry spend at the supermarket? So we got there at this time. He left here. So we have 30 minutes and 90 minutes. And 90 minus 30, that'll be 60 minutes. Or 1 hour. The next question then was, what time did Barry return home? Okay, so he left at 4 o'clock and then he came back then, so it's 110 minutes later. So 110 minutes is equal to 1 hour and 50 minutes. So adding that onto 4 o'clock, it will be 5:50, and we'll write that as 17:50. So he arrived home at 10 to 6. Last question now. So we need to compare Barry's speed travelling to the supermarket and returning. And then why could the speeds be different if it was the same route? So, first one there. So the distance is 30 kilometers and it took him 30 minutes. So that's 30 minutes. Let's put that over 60, so that'll be 0.5. And then let's go to our triangle. So we're looking for speed, so we'll cover that. So distance divided by time, 30 divided by 0.5, that is 60 kilometers per hour. Returning then, so again we have a distance of 30 kilometers, but it's only 20 minutes now. So we'll put 20 over 60, which is a third. And now we'll do 30 divided by a third, and that is equal to 90 kilometers per hour. So we can clearly see he was a lot faster on the return journey. And the reason for this is when he was going to the supermarket, there may have been a lot of traffic. And when he was returning then, the roads may have been a lot clearer. So I'll just write that now. So there we have it. There may have been a lot of traffic when he was going to the supermarket. Okay, so any questions, please leave in the comments. Thank you.